How does big O notation work for execution steps? Remember, big O notation for execution step is called also time complexity. It measures how smart is your algorithm, and I have prepared this simple example in order to illustrate how can we measure the big O notation or time complexity for this algorithm. So we're given this list starting from 0, 1, 1, 3, 5, 6, 7, 8, 9, and 10. This list is sorted. So I'm gonna ask you here to find 7, and you can just look by looking. How can you find 7 here? And it's very simple, it's in front of you. So now moving on, and I want to hide those kind of 2, 4, 6, 8, 10 elements. I want to hide them, and I want to write an algorithm for the computer to use to find these 7. So let's hide it and measure the steps that require to find these 7. Alright, so first we're gonna start at the beginning. We unlock this. It's not our 7. We're gonna keep going to the next and find. So we are at the second step. We didn't really find 7. We're gonna at third step, not 7, fourth, 5, 6, and now finally, in order to find the 7 element, we took 7 steps, 7 complete steps just to obtain this 7. So what is our algorithm work on? It took 7 steps to find the number 7. That's the algorithm that we have made right now. And for our best case, possible case, we can have 1 step just to get the first sorted number. So if we search it for 0, it would take us 1 step. That would be amazing. But if we wanted to search for 7, it took 7. If we wanted to search for 5, it's going to take 5. So that's for the case we implemented 7 steps, and for the best possible, we can have 1 step. And now for the worst case, we will need to have a steps as size of the list to get last sorted number. So let's say we want to find this 10 number, last number. We would take like 8, 9, and 10 steps. This is the same size as this list. So we're gonna call it as n steps. The n is the size of the list. So we're gonna take n steps just to retrieve the last sorted number, which is gonna be the same size of this list. That's for our worst case. And when we're gonna talk about big O notation, we take the worst case and we just call it big O of whatever is the highest possible number of steps. So in our case, we called it n because n is the size of our list. So at worst case, it's gonna be at the size of that n. So it's gonna be called big O of n. We're gonna short it of O bracket n close the bracket. So overall, the big O notation, or you can call it time complexity, for this algorithm to be executed, it's gonna be O of n. This is how can we calculate the big O for an algorithm for using execution steps that's being processed by processing unit like CPU or a GPU. Now we're gonna talk about smarter algorithm. It's gonna be the same list, but it's gonna be smarter algorithm. The algorithm that we're gonna use is called binary search. If you're not familiar with binary search, it's okay, don't panic. We're gonna show visualization here. It's the same list, but we need to take care of how many steps we have taken. Remember, previously we have taken 7 steps just to reach 7. Right, for this example, we're gonna take we want to also search for 7. So first we're gonna find the middle one. The middle one is, we have taken 1 step here just to get the middle. In our case it would be 5, which is 4 here, and we're the middle of this. It's like 2, 4, 6, 8, 10, and we want to find the middle. So the middle here would be at our middle, which is in our case 5, and this one took 1 step. 1 step just to eliminate all the previous one because we know it's already sorted, so we just remove the left side because we know we were searching for 7. 7 is greater than this 5. So basically, since 7 is greater than this 5, we're gonna remove all the left side. And this is first step. Now we need to find the middle of this right side. So the middle of this right side is this position. So we're gonna look at it. It's 8. It's not 7. 7 is smaller than 8. So we know it's in the left side. So we're gonna remove all the right side. Alright, that took us 2 steps. Now we want to find the middle at this position. Since they are just even, we're gonna take the second position. It basically, you based on your algorithm, you can have this one or this one, but basically I'm just gonna choose this one for now. This one is 7, which is basically the number that we needed. 3. We took 3 steps just to find 7. Instead of 7 steps, we have taken 3. That's a lot better than 7 in terms of large scale. So if you considered large scale number, you would find amazing results using this algorithm instead of just this the linear search that we have implemented before, just checking step by step. So in this algorithm we took 3 steps just to find number 7, and the best case would be, first we're gonna have one step which is at the middle sorted number, not middle sorted number, but in the middle index of this list. And for the worst case, and the worst case here is log of n. What does that mean? We're gonna take, let's say you have an array of integer of 8 numbers. You're gonna at most gonna take 3 steps just to find whatever number you're gonna need using this algorithm. That's really amazing. That's a huge advantage, better than iterating 8 times. You're gonna iterate 3 times. So this way you can kind of make sure you made a lot of progress, saved a lot of steps, made the execution steps as low as possible in terms of your algorithm. This one will show how can you improve a lot in terms of your algorithm. And given if you wanted 130 or less 125 in this range, if you wanted to have an size of 125 element, that would take you 7 steps just to find whatever you need. I'm just giving this number for illustration purposes. So basically this algorithm is better. And if we wanted to calculate the big O notation for this algorithm, we're gonna take the worst possible case. When we call it big O of that worst case, and that worst case is log of n. Log 2 is big O of log n, and we're gonna short it for O bracket log n and close the bracket. So overall, the big O notation or time complexity for that algorithm is O log of n. That's way better than the previous algorithm that's gonna be iterated to the whole size of the array. That's much better. And this is how we can measure the performance for the execution steps as big O notation or time complexity, if you would like to call it that way.